Show of hands, who here likes using the baked-in state management tools in React that use dependency arrays like useEffect, useCallback, and useMemo? You don't? I'm shocked. Of course I'm not. I ran a poll on Twitter a couple weeks back where 37% of respondents who work with React applications said that they use the basic built-in hooks. The overwhelming majority of folks said that they use an external state manager like Zustand or Redux or one of the other externalized state managers to manage their state, or a combination of hooks and a state manager. Contrast that with coders on other frameworks like Vue or Solid or Svelte, who overwhelmingly use the state management solutions baked right into their frameworks. Why the difference? I think it's dependency arrays. In all honesty, dependency arrays are just terrible. The best thing you can do with a dependency array is not screw it up, and that's not great. These other state management systems are just so much easier to use. But do we have an option? Can we use any kind of state manager to manage local state? I mean, that's crazy. Global state managers are global state managers, right? Well, no, not really. Actually, we can use global state managers locally. And that's what we're going to do in this video. I'm going to show you how to use Zustand, Valtio, and Jotai to manage local state and do it without any of these dependency arrays. Now, before we get into it, I'm super excited because we have another great sponsor this week, and that sponsor is Brilliant. More about them in just a bit. Let's get right into it. All right, now this is our starting point for our experimentation into how to use global state managers to manage local state. The completed project is over in the GitHub link that is in the description right down below. I'm going to start all of these different directories. We're going to start off building the hooks-based solution. Then we're going to go to Jotai and Zustand and Valtio. Each one of those is going to go in its own directory. And so you'll have at the end a directory full of different approaches to solving this particular problem. So what is our problem? Let's go take a look in the browser. So our problem is that we have 4 different chat systems going on simultaneously here. So there's a chat here, chat here, chat here, and they're all supposed to maintain their own separate context. Imagine, if you will, that this is the chat system of LinkedIn. You're probably familiar with that, where it's got all the little chat boxes at the bottom. You don't want your chat going to one person to go to somebody else. So it's critical that the context is maintained and each chat is maintained independently. But you want to do it in a sane way. So that's what we're going to do in this application. We're going to manage that by context to start, but then within the context, we're going to use a React hook in the hooks application, but we're going to use a Zustand store and a Valtio store and a Jotai store in each one of those solutions to manage the state within the context. Okay, let's go take a look at our starter code. All right, so I'm going into the starting point directory and then into app.tsx. This is the one file where it all happens. So up here we have our chat context. That's what we use to wrap inside of the chat container the chat. So that's going to give you, each individual chat is going to have its chat context. So we've got the chat context that we create up here. We started off with null. That's clearly not going to work. And then we give it a value down here as we integrate it into our chat container. Our main app just has a bunch of these chat containers inside of a chat area. All of the CSS is over here, I think in index.css. There you go. So our chat component here uses a bunch of custom hooks. These custom hooks give us what we need to run our chat. There is a custom hook that gives us our messages. That's an array of strings. There is one that gives us the current message. That's what we're typing into the text box. There's one that gives us the message count. That is a derived value, and I wanted to show that because that shows the equivalent in these frameworks of a use memo that has a dependency array. So that's one of the things I wanted to get to was, yes, this is a simplistic example, but I wanted to show some core mechanics when it came to state management. One of those is derived data. And so this message count is how I'm going to show that. Then set current message is simply, hey, I'm typing in there. I just want to update the current message. And then add a message means take the current message, add it into the array, and then set the current message to blank. That's pretty much it. Then down here in our JSX, we're going to go and iterate over the messages. We're going to go and have a message count, displays the message count. We're going to have our input, which just goes and does set current message. And then we're going to have a send button that does our add message. All right, so don't worry if you didn't follow along with that 100%. As we go and implement it out, you'll understand more about how this all works. So let's go and take this starting point and create our use hooks application. And that's going to use native React hooks to do this. So I'll copy that starting point directory recursively into use hooks. Then go into use hooks and install it. And then bring it up in development mode. All right, let's go over to our use hooks and then down into app.tsx. And now I'm going to go create a use chat store custom hook that's going to manage our chat store. So now I need to connect that through the context. So the context is either going to be null or the return type of this hook. Now down in our container, we've got to instantiate that hook. And then send it along as the value. So now down in our custom hooks over here, we can get access to whatever is coming out of use chat store through that context. So what's going to go in use chat store? Well, we have some state. We've got messages and we got the current message. And then we've also got a message count, which is just going to be the use memo of the messages.length, which is whatever, it's fine. So let's go bring those in. Now let's define our state. Our messages are going to be an empty array of messages. Our current message is going to be a string that starts off at an empty string. And then we are going to output that as the output of the chat store. Now I'm not going to add set messages because that's going to be part of our add message function that we're going to add in here. So we don't actually want to expose set messages outside of this hook. All right, now that we have those, we can go over here to our custom hooks and we can say, for example, we know that that's going to be there and we can get the messages out of it. And then down, same thing with the current message. And also set current message. Now we need our message count. That's the number of messages in our chat. And for that, we're just going to use memo and then get the length out of it. You don't even really need a use memo in this case, but I did want to show how React hooks do derive state. And primarily that's through the use of something like use memo. Why don't I need to use it in this case? Because the calculation in this case is trivial. Arrays always know their length, and returning the array length is not a big deal. If it were a permutation or something that I needed to do on that array, that's when I would use a use memo. Again, though, I did want to show how these dependency arrays would work in this particular example. All right, let's now take that message count and output that. Again, we'll connect it to our custom hook. And then finally, we need to implement on use add message. So what is that? Well, use add message is going to add the current message to the array of messages, and then it's going to set the current message to blank. So let's go and create a function that does that. So this add message function is going to set the messages by taking the current list of messages and just appending the current message to it, and then it's going to set that current message to blank. All right, let's take that add message and connect it to our custom hooks. And if you're wondering why the bang here, well, that's because use context could potentially be null. In real life, you'd want to go and check to make sure that chat context isn't null, but in this case, it's just a little bit easier to use the bang syntax and say, yeah, I know it's not going to be null. All right, let's get rid of our no op and see, does this work? All right, let's do hello here. Hit send, and there we go. And we have complete isolation between these. For example, if I go over here and I say goodbye, in a different chat, the person that I say goodbye to isn't going to be the person that I said hello to, and that's exactly what we want. All right, so we have the fundamentals down. And speaking of fundamentals, there's no better place to learn fundamentals than on this week's sponsor, and that's Brilliant. If you're interviewing for a programming job, which I know many of you are now, you really need to have those fundamentals locked in. And Brilliant is a great place to learn that. Big O notation, binary search, parallelism, graph theory, it's all in there. And they make it really easy to learn and then retain all that information because of the way that they teach it on the Brilliant site. Sitting in front of a YouTube video, as much as I appreciate it, is not going to help you deeply learn those skills. You need to have that hands-on experience, and that's the way that Brilliant works. If you're a visual and interactive learner like I am, you enjoy playing with things. I'm learning data analysis on Brilliant right now, and I gotta tell you, the ability to go in and change graphs and see how does this affect the mean, how does this affect the mode, that is fantastic, and it really helps me retain that information. And the lessons are short. You can do 3 or 4 of them in an hour. The kids are off playing soccer. Just spend a little time on Brilliant, crank out a few more lessons, and it will keep track of those for you so you can keep a streak going. And that helps me make sure that I keep in my learning groove. This data analysis course that I'm taking is just the first step in my journey into AI. And Brilliant is a fantastic place to learn about artificial intelligence. They have several courses on neural networks, machine learning, and AI, and I can't wait to dig in because I love how they structure their courses and how interactive they are. Now, if you want to learn AI like me, you're going to probably want to learn Python, and they have a full end-to-end course in Python. And again, it's interactive. You're not just watching videos, you are actually coding right there in the browser and seeing the feedback right there. To try everything Brilliant has to offer, free for a full 30 days, visit brilliant.org/Jack Harrington. The first 200 of you will receive 20% off of Brilliant's annual premium subscription. Okay, now that we have our fundamentals down with our use hooks example, let's try another state manager to see how we can use a global state manager to solve this a little bit easier and not have to deal with things like these dependency arrays. Well, the first one I'm going to try is Zustand, Z-U-S-T-A-N-D, and it's a popular alternative to Redux since it works on a similar model. So again, I'm going to start with our starting point and copy that into a use Zustand directory. All right. Now I'll go into use Zustand, and I will add Zustand because we need it. And then I'll run dev on this to bring the project up. All right, looks like what we just had before. Let's go and implement on Zustand. All right, so over here in our app.tsx, we're going to bring in create store and use store. This is slightly different than what you might have experienced before if you've been working in Zustand, where you bring in create. So create store is Zustand v4's way of creating a store that is disconnected from React. Just means that you don't get that hook. What you'd use instead is use store, and then you give that the store reference as the first argument, and then your selector as the second argument. Just a nice, clean way to use a Zustand store. All right, so let's define our store creator. This is going to be a function that uses create store to instantiate a new store. And we're going to have a store per context. So let's go take a look at how this is going to work. So we're going to have a create chat store function. It's going to return a create store. The topology of the store is going to look like this. We're going to have a current message, messages, set current message, and add message. Look familiar? Pretty much exactly what we had with the hooks. And then in Zustand, you have a set and a get function that you give to the store, and those you can use to get and set the current values from the store. So let's just start off with the easy ones. Current message and messages, so that's going to start off with an empty string and an empty array. Set current message is where it starts to get a little bit interesting. We've got a value here coming in, and then we use that value in a setter to set the current message to the incoming value. Pretty easy. And then our add message simply does a lot of what we did with that hook. We're going to go and set the messages to the original messages array plus the current message, and then set the current message to an empty string. All right, so let's get to using this thing. We've got our create context down here. We're going to have null, we know that, but we also need to have the output of whatever this store is through create chat store. So we're going to take, again, the output of our create chat store, and we're going to say it's either that or null. And then down here, in our container, we need to have some way to hold a store. So for that, I'm going to use a ref. So let's bring in use ref. And then down here, I'll create a store using use ref and invoking that create chat store. Now that we have our store, we can go and pass that as the value by doing store.current, because the current in a ref has the current value. This just means that we're never going to recreate this store if this chat container gets re-rendered. The ref starts off with a value, and unless you change it, it's going to keep that value over time. So that's how we're going to persist this chat store. Okay, so now that we have our chat context provider loaded up with our Zustand store, we need to now go and connect that to our custom hooks. So our use context contains the store. So with that store, we can use useStore. So we're going to drop useStore in here and give it that use context as the first parameter. And then the second parameter is a selector. So in this case, we're going to select out messages. All right, similar kind of thing with our current message, as well as our set current message and our add message. All right, so the last one we have is our use message count. So that's going to have the length of the messages array. That means it's derived data. So whenever messages changes, we're going to want to go and update that. Now, there are a bunch of different ways to do derived state in Zustand. It really depends on the complexity of the derivation. This is pretty simple. So what we're going to do is just use a selector in this case. So we're going to go take this messages, pop that in there. And instead of just giving messages, we give messages.length. This is a pretty common thing in this selector model. You go and add things together, or you can do some sort of logic inside of the selector, and that's what we're doing here. All right, let's go see if this works. I mean, it should work. Let's go try. All right, looks pretty good. Let's do hello here. Yeah, nice. Awesome. How easy is that? Let's wrap this up by getting rid of the no-op. And there you have it, a really nice, clean implementation of using local state, but with a global state manager through Zustand. So if you're tired of using React hooks to manage your state and you want something a bit more sane and Flux style a la Redux, this is probably a good alternative for you. Well, maybe you don't like the Flux model. Maybe you want something that's more akin to MobX. Is there a proxy-based state manager that you can use in a local context like this? Absolutely there is. It's called Valtio. Let's take a look at how we do that next. All right, I'm going to bring back up the console, and I'm going to go create the use Valtio directory. Then I'm going to jump in there and add Valtio. And then bring it up. Okay, looks good. Let's start off with our use Valtio implementation. So in Valtio, you create a proxy object, and you can just set values on that object to set things. To get values, you have to use what's called use snapshots, custom hook, but it's pretty easy to do. So let's go and bring in proxy and use snapshot from Valtio. Now we are going to create our create chat proxy function, and within it, we're going to use that proxy function to create our proxy data. In this case, that would be the current message. The messages is an empty array. And we get to define derived data by just using a getter. So in this case, we'll have get message count. And anytime you do .message count on this object, it'll run state messages.length, and that'll give us back the current count of messages. All right, so what is our context going to be? Well, it's going to be the return type of that function, or null. And again, we want to use a ref to maintain that down in our chat container. So we're going to create our chat store and then pass that off to our provider. All right, so now let's go change our custom hooks. So we're going to use snapshot here and give it that store. And then coming out of that is going to be our messages, our current message, and our nicely derived message count. I mean, come on, how easy is that? But then there's a little difference, because with Valtio, you get to set data directly, which I think is really cool. So what we need to do is just basically give it a way to get the store. And so what we're going to do is we're going to call that use mutable state, and it's going to get the store. So down here, we're going to get our store using this use mutable state. And then to set the message, all we got to do is just set the message. Crazy, right? And then on add message, well, we can just go and make those changes ourselves. So we can use push to push the current message into the store.messages, and then we can just set that value to an empty value. Pretty easy. And that's one of the great things about these MobX style proxy stores. They work kind of like a spreadsheet. In this case, we know that get message count relies on messages. And so when we add a message to the store, Valtio automatically does all the work of tracking all of those dependencies. We don't have to maintain that dependency between these two pieces of data. which is just so much cleaner than what we have to do with dependency arrays. All right, let's save this out and try it out. All right, looking pretty good. Hello. There we go again, our classic hello there. Goodbye. Awesome. And we'll say that this one's Valtio. That's great. Really nice. Really clean. A very nice, easy implementation for local data that has dependencies managed in a much more sane way. The last one we're going to look at is Jotai. Now, you might not be familiar with what Jotai is, but you might have heard of a library called Recoil. So Recoil came out from Meta. It is a state management library that uses the atomic model. So you define state as atoms. So our messages will be an atom. Our current message will be an atom. And then you can define relationships between atoms. You can create a message count atom that derives its data from the messages atom. And you use it just like you would any other atom. It's just a really clean way to work with data. Why did I choose Jotai over Recoil? I just happen to prefer Jotai. I think it's a much more well-maintained library, and there are a bunch of extensions to Jotai that allow you to integrate things like Immer, XState, React Query, TRPC, and so much more. It's just a fantastic library. All right, let's go and try out Jotai. I'll close these up, go back into our terminal, and we'll do our final copy into use Jotai. And now we'll add Jotai. Now we're not going to use any of the additional libraries. We're just going to use the main Jotai core. All right, let's fire it up. Looks good, a good starting point for us. Let's go and try it out. Let's go back over here to our app.tsx file. And we'll bring in a bunch of things that we're going to need from Jotai, including primarily the atom. And then create store is going to allow us to create boundaries in our atom model. So anytime you create store, then you're creating a store that can hold multiple atoms, and they create kind of unique contexts. So it's kind of like context in a way. Yeah, it is like context. Yeah, there you go. Use atom and use atom value are custom hooks that work within React context. Use atom returns a tuple similar to use state, so it's got the value and then a setter, and use atom value just returns the value. Okay, let's go create our atoms. So the first two are going to be pretty easy. We've got a messages atom that has our array of messages, and we've got our current message atom, which has an empty string. And then we're going to create our derived atom. So this is going to be our message count atom. Atom can also take a function. And in this case, that function gives a get parameter. You can then get an atom and then derive some data off of it. And what it does is it subscribes the message count atom to the messages atom, such that when the messages atom changes, the message count atom automatically updates. Now, notice I'm not creating any kind of creator here. So what are we going to put in our context? Well, the context is going to contain the output of a create store. So we need a use ref to hold that. And then down in our container, we're going to invoke create store to get our chat store, and we're just going to pass that along as the provider value. All right, cool. Now we have a Jotai managed store that will give us the value of messages for each store and the value of message count for each store, independently of each other. All right, let's start off with messages count. And we'll drop this in here. This is going to call use atom value. We give it the message count atom, and then we give it an optional object that tells it which store to use. And the store we're going to use is from the context. Pretty easy. We'll do the same thing for our current message, as well as our use messages. Now for set current messages, I'm actually going to bring in use set atom. And that just gets us the setter as opposed to the value. So let's try that out. And that'll be on the current message atom. Awesome. And you know what? Let's actually have a use set messages that does the same thing for messages. Okay, now let's do that down here. All right, now we have use set messages, and we've got set messages. Okay, and I think the only thing we have to do down here is do something similar to what we had before. where you set the messages to the current messages plus the new current message, and then set the current message to an empty string. All right, let's try this out. Awesome. Works perfectly. And no dependency arrays. We have this automatically managed connection between the messages and the message count right here, which is automatically updating, which is exactly what we want to see. This is really, really clean. I guess we didn't need to use Atom after all, and we don't need that no-op, and that's going to give us a nice clean code base that you can try out for yourself. So there is another way in Jotai to model the add message functionality in here. You can have a write-only Atom that would then manage the connection between messages and current message and do all of that logic for you. So there are ways to go and encapsulate functionality outside of, well, in this case, a click handler. So definitely a good thing there. So there you have it. 4 different ways of maintaining local state in React. You've got the regular React hooks model, which we've all been familiar with, but apparently don't like all that much, which I totally sympathize with. And then we've got the Jotai model if you want to do a atomic state. You've got the Valtio model if you want to do a MobX style state. And you've got the Zustand model if you want to use a Flux model similar to Redux. Of course, I would love to hear from you in the comment section down below. Are there state managers that I should have used or state management models that I should have used that would be even better than this? Is this something that you would consider doing in a normal React application? Let me know. In the meantime, of course, if you like the video, be sure to hit that like button. And if you really like the video, be sure to hit that subscribe button and click on that bell and you'll be notified the next time a new Blue Collar Coder comes out.